Now that we've looked at the derivatives of polynomial and rational functions, and also functions involving e to the x, we're ready to explore derivatives of trigonometric functions. We're going to start with the sine function, and before we do any calculations for the derivative, I want to sketch the graph to remind ourselves what it looks like, and we're going to use the graph to get an idea of what the derivative might be. So let's start off by looking at y equals sine of x. All right, take a moment to think about what the graph looks like. If you don't know where to start, you can pause the video. All right, so first of all, if we start at 0, sine of 0 is equal to 0. So this graph goes through the origin. If we look at sine of pi halves, sine of pi halves is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. And if we look at the negatives, we're going to get something similar. You probably know what the graph of sine looks like. You know that it is a wave. And we can connect the dots in this wave. Mine's not going to be perfect. I'm doing this on an iPad, and it's not really grippy, so it's very easy for the Apple Pencil to slide a little bit. Anyways, this is a very rough sketch of the graph of sine of x. Let me label the axes, make it a little bit nicer. So this is a graph of the sine function, and what I want to do without doing any limit definitions of derivatives or anything, at least to start with, I want to get an idea of what the graph of the derivative might look like. So let's figure out what the graph of the derivative of sine of x might look like. All right. So the easiest thing to do is to look and see where we're going to have horizontal tangent lines. Because if we have a horizontal tangent line, that means that the slope is 0, and that means that the derivative is 0. So my graph's not the best one in the world, especially at this important point right here. I've done a crappy job, but if you'll allow me just a little bit of patience. At pi halves, we have a horizontal tangent line. That means that the derivative is going to be 0 at pi halves. Also, at 3 pi over 2, we've got a horizontal tangent line, so the derivative is 0 there. Also at negative pi halves and at negative 3 pi over 2. So we can see the derivative is going to be 0 at these places. Now, if we want to look in between where it's 0, if we look at this interval in the middle, we can see that the graph is increasing. That means that the derivative is going to be positive. So between these points, the derivative is positive. And it looks like it's not that steep at first, and then it gets steeper, and it reaches its steepest point here, and then it gets shallower and shallower. And so the derivative is going to grow and get bigger and bigger. We don't know exactly how big yet. And then it's going to get smaller and smaller. If we look at this graph, now the axes aren't exactly the same, but the slope here looks like it could be about 1. That might be a good guess. So if we said that the slope is 1, and we said that it was increasing, and it reaches a maximum and then decreases a bit, might look like that. If we look on this next interval, the function is decreasing. So we know that the slope of the tangent lines will be negative, which means the derivative will be negative. And it looks like it's going to reach its maximum, the minimum, like the maximum steepness as it goes down around there. So it looks like something like this. And if we look to the left, to the next interval, looks like it's going to be something like this. We can keep going. And on the right, it's going to keep going. Take a look at this graph and think about what it might be equal to. Can you think of a function that's periodic? It has zeros at the odd multiples of pi halves. It is positive here in the middle. Hopefully you're seeing what I'm seeing, and we might guess that this might be equal to cosine of x. But to know for sure, we need to look at the limit definition. So let's take a look at the derivative of sine of x. So this is going to be the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Now, we need to do something because this is an indeterminate form. We cannot just plug in 0 here. So what we really want is we want another way to write sine of x plus h. And for this, we go to our trigonometric identities. And we know that we have a formula for the sine of a sum. Sine of x plus h is going to be sine of x cosine of h plus cosine of x sine of h. And then we still have minus sine of x all over h. Now, there are two terms here that have sine of x in them, and one that has cosine of x in it. And so what I want to do is I want to rearrange things and put all the sine of x terms together, and then all of the cosine of x terms together. So let's start with the terms that have sine of x in them. We've got sine of x times cosine of h minus 1 over h, right? Because we've got sine of x times cosine of h minus sine of x just times 1. And then if we look at the cosine of x, we have sine of h over h. Now, when we look in this limit, we can separate this into two limits, the sum of this first limit plus the second limit. And notice that the limit is as h approaches 0. So sine of x and cosine of x are effectively constants with regard to h. They don't have h's in them, so we can pull those outside of the limits. So when we split this into two limits and pull out the sine of x and cosine of x, we have sine of x times the limit as h approaches 0 of cosine of h minus 1 over h plus cosine of x times the limit as h approaches 0 of sine of h over h. Now notice that both of these limits don't have x in them anymore, which means that if these limits exist, they are just numbers. So our derivative is going to be sine of x times some number plus cosine of x times some other number. And what we want, because we want the derivative to be cosine of x, we want this limit to be equal to 0, and we want this limit to be equal to 1, because if that's true, then the first term vanishes, and then we've got cosine of x times 1, which is cosine of x. Now, to evaluate these limits, we would need to make tables of values, and this video is already 9 minutes, so I'm not going to do that for you. If you really want to see those tables of values, you're going to have to make them yourself, but I will tell you that these limits are equal to 0 and 1, respectively, and so in the end, we have sine of x times 0 plus cosine of x times 1, and so our derivative is going to be cosine of x.